Okay, in this video, I'm going to explain about the dynamic routing protocols. Okay, the first objective that we're going to achieve is to know the function of dynamic routing protocols and to know the purpose of dynamic routing protocols, the use of dynamic routing and the static routing. So these are the three objectives that I would like you to know, okay, for this section. Okay, for the dynamic routing protocols overview, this is the distant vector routing protocol with the RIP version 2, with the RIP NG, next generation. Okay, EIGRP with the EIGRP for IPv6. Now all these category here will be under the interior gateway protocol. So interior gateway protocols consist of distant vector, okay, and also the link state routing protocol. So our focus for this syllabus will be here, interior gateway protocols, which consists of the distant vector routing protocols for RIP version 2 and EIGRP. And for the version 6 will be RIP NG, next generation, and also EIGRP for IPv6. And if we talk about the link state routing protocols, it will be OSPF version 2 for the IPv4 and OSPF version 3 for the IPv6. So this one and this one is not the coverage for this topic yet, okay? Okay, so RIP protocol was updated to RIP version 2 to accommodate the growth in the network environment. RIP version 2 does not scale to the current larger network implementation. Because of that, the routing protocols developed to meet the need of the larger networks include OSPF, ISIS, and EIGRP. So EIGRP stands for Enhanced Interior Gateway Routing Protocol. As for the Border Gateway Protocol, which is the BGP, is used between Internet Service Provider. Okay, so what is the purpose of the dynamic routing protocols? So the purpose is to discover of the remote network, to maintain the up-to-date routing information. That's why we need to have the dynamic routing protocols, to choose the best path to reach to the destination network. And for the dynamic routing protocols also, there will be the ability to find a new best path if the current path is no longer available. Okay, so this one will be very effective for you to use it for the dynamic routing protocols. So the main components of the dynamic routing protocols include data structure, which is the tables of database kept in random access memory. You will have the routing protocols messages to discover the neighboring routers, exchange the routing information, and maintain the accurate information about the network. And also the main components of the dynamic routing protocols will include the algorithm. So these algorithms were to facilitate the learning routing information and the best path determination. Okay, so we talk about the static routing users. Network often use both static and dynamic routing. But then static routing is used for easy table maintenance in the small networks. So if you have the small networks, you can implement it for the using the static routing. And then we have a routing to and from a stub network. So if you have only one neighbor to reach to the stub networks, you can use the static routing. And static routing also good when you use it as a single default route. Okay, when you want to access it to the internet service provider. Example in this case here is the R2 go to the internet. So this router 2 is good to configure the single, which is the default route. Okay, static routing advantages and disadvantages. For the static routing advantages, it's easy to implement in a small network. However, it's very difficult for a simple topology or for special purposes such as default static route. So this is the disadvantages of using the static routing. But then static routing is very secure because no advertisements are sent as compared to the dynamic routing protocols. As for the static routing protocol, the disadvantages is configuration complexity will increase as the network grows. So the advantages of the static routing will be a route to the destination is always the same. But the disadvantages is that you have to manually configure it, which is a manually intervention required to reroute the traffic when there is a change in your network topology. Okay, so even though it's secure, but you need to have your manpower to manually configure it. And for the last advantages of the static routing is that no routing algorithm or update mechanism required. Therefore, extra resources such as CPU or random access memory are not required. So this is a good thing about the static routing. Okay, now when you look at this diagram here, you will see that if your network growth, you have a region 1, region 2, region 3, region 4, it is impossible for you to configure a static routing, okay? Because you have to configure it one by one for you to route to each path. And if anything failure for this router, you have to quickly go to this router, whoever to connect to this router, and you have to change your configuration manually, which is a very tedious job for the network administrator to do that. That's why the dynamic routing protocols is being implemented, especially good for you. It's the best choice when you have a large networks. Okay, so the dynamic routing protocols help the network administrator to manage the network. This dynamic routing protocol will provide a redundant path. And the good thing is that it will automatically implement the alternate path when a link goes down. So if let's say this one got a breakdown and failure, so it will automatically route from this router to here, okay, or to here and to reach to the destination. So that is a good thing about the dynamic routing protocols. So this slide is talking about the advantages and disadvantages of the dynamic routing protocols. Of course, for the advantages, the dynamic routing protocol is suitable for all the topologies where multiple routers are required. So for the big networks. But of course, it can be more complex to implement for disadvantages. And for the dynamic routing protocols, generally independent of the network size, but because of its independent of the network size, it is less secure. So additional configuration settings are required to secure each of the networks. The advantages of the dynamic routing protocol is automatically adapt topology to reroute the traffic if possible, which is very good and it's very efficient. Okay, but the disadvantages is that the route depends on the current topology and it requires a lot of additional CPU, RAM, and the link bandwidth to maintain it. So there's the pros and cons about the dynamic routing protocols. Okay, so in this session, I'm going to explain about the RIP version 2. So RIP stands for Routing Information Protocol, which is a version 2. So implement the RIP version 2, you're going to learn about how to write the configuration to configure the RIP version 2 routing protocols. Okay, at first, how do you do the configuration is you have to activate the command keywords for the router RIP. Okay, you have to activate this command router RIP for the version 1. So if you just type the word router RIP, okay, that means you are actually enable the RIP version 1. So use the word no router RIP command to disable the RIP. So you can just use the, when you go, if you want to remove this router RIP, you can just put the word no router RIP. Okay, so retype that, then you can remove this configuration command. So the second thing is for you to configure the network address when you use the RIP. You have to advertise your network, directly connected networks to inform your neighbor router what is the network that directly connected to you. So in order to do that, you need to configure a network address. Now, for example, here you are in the router R1. So R1 is directly connected to 192.168.1.0. and R1 is directly connected to 192.168.2.0. So when you configure the router configuration for the RIP, so you can just activate router RIP. Okay, to activate it, when you just do this, router RIP by default is using the RIP version 2. Okay, so RIP version 1 is a classful routing protocols for IPv4, but the version 2 is a classless routing protocols. So you have to configure a network, which is the network 192.168.1.0. okay, without any default gateway if it is by default. Because 192 is a class C, so by default, even though you put 255.255.255.0, when you show IP route, it will just convert it back to original because it is a classful address. And you have your network 192.168.2.0 to advertise the network of this network. Okay, so this is the network command, and once it is successfully done, the router will going to advertise these RIP routing updates every 30 seconds when you use the RIP. Okay, so there is the concept of router routing information protocols. Now, how do you verify it? So you can show the IP protocols to display the IPv4 routing protocols configured in your router. So when you do this, when you show the IP protocols, by default, just now you just type the RIP version 2, right? So by default, it's already using the version 2. Okay, this is automatically support. So you can just prove it by show IP protocols. So you can just see here the receive is actually using the version 2. And this is another way for you to show the IP route that you configure the 3 commands just now to reach to your network. So just now you have the configuration for that networks, and if it's everything successfully, you will route to the remote networks. So according to the remote networks, for if you are using the RIP routing, it will be denoted as R in your routing tables. So this is R, this is R, this is R. Okay, this is the using the routing information protocols. So here it will just tell you that in order for you to route to the remote network of 192.168.3.0, then you have to pass by the next hop IP addresses of 192.168.2.2 and so on. So if your everything configuration is correctly being configured, you will have 3 remote networks, okay, to reach to the destination. So how do you prove it? You can just show IP route, or you can just put the pipe and begin gateway. So it will just show you the active RIP. Okay, in order for you to enable the version 2, you can just go to the type the router RIP version 2. Now, if you notice that just now I only have a receive for the version 2, but when I sending here, I can only send to version 1 because my configuration earlier on, I just put a router RIP, but I didn't put the version 2. So by default, when you use a router RIP, but you forgot to put the the version 2, it is using the RIP version 1. Okay, so be careful when you want to use the RIP version 2, you need to type this command, extra command to activate it, which is the version 2. Okay, so once you type this version 2, when you show the IP protocols to check whether you are using the version 2 or not, you will appear these two, send and receive is both using the version 2. So this is the correct configuration if you want to apply the classless routing information protocol for the version 2. Only the RIP version 2 compared to the version 1, RIP version 1 is a classful address. That means it cannot support the subnet mask. But then if you use for the VLSM and CRDR as well. But if you want to support the VLSM and CRDR, you can implement the RIP version 2 because it supports the classless address. Okay, this is how you disable the auto summarization. RIP version 2, because the nature of the RIP version 2 will automatically summarize the networks at the major network boundaries. So you have to use the no auto summary, okay, for this router configuration mode to disable the automatic summarization. So in order to do that, once you have your no auto summary ready, you can just show IP protocols to verify that the auto summarization is off. Okay, so you can just say here the automatic network summarization is not in effect. So that means you already successfully implement the switch off the no auto summary when you issue this no auto summary. So you don't allow the router to do the automatic summarization. The reason why you have to use the no auto summary, as what I mentioned just now, is to disable the automatic summarization. We don't want it because the nature, by default, is using the auto summary. So you have to turn off this auto summary. And this is the concept of the passive interface. Now, the passive interface means that you are not going to send the routing updates to the end device. You only send, no matter what dynamic routing protocols you have, you are communicating from router to router. So sending the routing updates to the end device is not necessary. So that's why you need to have to passive the interface so that you block that interface to broadcast the address to outside of the end devices. Okay, that is the first. So all the forwarded out RIP enable interface is actually by default. So only need to be sent out interface when you are connected to the routers. But if you connect to the end device, yeah, you don't have to do so. So you have to passive it. What is the main issue if you don't block this? Let's say R1, you don't passive in this interface. Router 2 is connecting to the switch. In fact, you don't have to send the routing updates to the switch, right? You just have to send the routing updates to router, which is router 2 to router 3, router 2 to router 1. And this interface, you do not need it. Router 3 also, this interface, you do not need it. So your broadcast message do not need to send out from this interface. Now, if you didn't passive it, it will waste a lot of bandwidth, and also it will waste resources, and also it will cause a security risk. The reason is because you are not communicate with the router. Okay, there's no router here, and you have to every few seconds, every 30 seconds, if your configuration is correctly being done, every 30 seconds the router 3 will going to advertise the network out of these devices. Wow, when there is a hackers comes in, it will be easily get your routing information updates freely, because every 30 seconds you are broadcasting out from the interface. But in fact, you are not the router, you're just the end device. So it is a very, a high security risk when you don't use a passive interface. So that's why it is encouraged for you to use a passive interface for the router configuration command to stop the routing updates out of the interface. So, but of course, you still allow that networks to be advertised to another networks. So passive interface is required, okay, especially for the router 1, G0/0. So when you want to configure it, you can use the command router RIP, and then you have to put passive interface G0/0 for the R1. Then you put the word N. So if you want to check your configuration is correct or not, you can just show IP protocols. So when you show the IP protocols, it will say here, the passive interface will not going to send out the updates go to this G0/0, but you are still communicating with this device. Okay, so there is no issue about the routing information. Okay, this is how you configure the passive interface. Okay, next we talk about the propagate a default routes. Okay, in your previous topics, we already learned about the default route, right? So in this diagram here, you are connecting to the default static route to the internet. So you configure the R1 default static route here for this interface of G0/0 to go to the internet. So this is how the command works. You go to the router 1, then you type IP route, _0, and then you have your exit interface, and you go to the next hop IP addresses, which is the 209.165.200.226. So when you configure the router RIP and you type the word default information originate, so this default information originate router configuration command, it will instruct the router 1 to send the default static route information in the RIP updates. Okay, every 30 seconds, it will instruct the routers, okay, the static routes configuration, to send the routing RIP updates. Okay, so this is how, why you need to have this default information originate. So the next session, we're going to talk about the routing tables. So I'm going to explain how to determine the route source and receptive distance and the metric for a given route. I'm going to explain the components of the IPv4 routing tables entry for a given route. And I'm also going to explain about the parent-child relationship in a dynamically built routing tables. Determine which route will be used for IPv4 and IPv6 packets. So these are the sessions you're going to focus on. Okay, these are all the routing tables entries when you show the IP route for your router R1. Okay, if you look at here, S star means it is the candidates of the default static route. C stands for directly connected networks. R is stand for the, this topology is using the router RIP. Okay, that means the RIP is actually denoted as R. You are using the the RIP routing protocols, okay, to use it for your configuration for this topology. Okay, is to access to the remote networks. So this is routing table entries. It will store the lowest, the best path to reach to each of the destination. So here, as a quick revision, as what I already covered in your previous chapters, for the C denoted in your routing table, when you show IP route, when you see the word C, is actually the directly connected networks. So this C will be automatically added into the routing table when the interface is configured and activated. Okay, so entries contain the following information, which is a route source. The route source, how the route was learned, whether it's a C or L, okay, or any other routing protocols. And you will have another parts of the category, which is the destination networks. So the one that highlighted in the the pink colors here, it is a destination networks. And after that, you will have another category of the outgoing interface. Now, this outgoing interface will show the exit interface used to forward the packets to the destination address. So other route source entries such as S, denoted as S, stand for static route. You have, if it is denoted as D, it is stand for EIGRP routing protocol, which is a dynamic routing protocol. If it is denoted as O, it means that you are using the OSPF routing protocol. And if denoted as R, you are using the routing information protocol. Okay, so these are the all for you to understand how are you going to read these the tables. So the routes to remote networks contain the following information as I mentioned just now. You have the route source, which is denoted as R or S or L or S star and so on. Then after that, followed by the destination network. This is your destination network. Now, followed by the first value here, indicated as the administrative distance. Of course, the lower the better. And this administrative distance depends on the depends on the protocol that you use. If you use the RIP, by default is 120. If you use the OSPF, by default will preview 110. And if you use the internal EIGRP, by default will be 90 and so on. So the next one, then next to the administrative distance value will be metric. So this metric, okay, the second value in the bracket here, is a value assigned to reach the remote networks. Of course, the lower, the better. Okay, and the next hop IPv4 address here, via. So via, this information here is to direct you to where do you need to route your packets. So it will route to the next hop IPv4 address. And for the route stamp here, it means the time since the route was updated. Okay, when is the time the route will be updated? And there will be an outgoing interface as well. There will be the exit interface to use and to forward the packets. So this is what we call outgoing interface. Okay, this is for your information, the routing tables for hierarchical structures. And the hierarchical include the ultimate routes. You have the level 1 parents route. You have the level 2 child's routes and so on. So we will go through these details in our next session. Okay, let's talk about the ultimate route. Now, an ultimate route is a routing table entry that contains either a next hop IPv4 address or an exit interface. That is ultimate route. That means you have the routing table contain next hop, either next hop or the exit interface. And directly connected dynamically learned and local routes are ultimate routes. Okay, so all these are the indicator of the ultimate routes. For example, in this table here, you have the next hop IPv4 address and you have the exit interface. So this will be your ultimate route. Okay. But for the rest of it, yes, it's still as an ultimate route, which is, let's say you have an R here, and then you will pass by the next hop route, next hop IP addresses with the exit interface. So all this is also your ultimate route. So just remember that ultimate route is a routing table entries that contains either a next hop IPv4 address or an exit interface. So this is your, all this, the one highlighted in the orange color is your ultimate route. Okay, next we go for the level 1 route. So the level 1 route can be the network route, can be the supernet route, and can be the default route. So it's very easy for you to determine the network route. So a network route that has a subnet mask equal to that of the class full address. Like for example, if you have 192.168.0.0/24, 192 is actually the class C. So if you /24, that is your network route because it has the subnet mask that equal to that class full address. Okay, but for the supernet route, it means that a network address with a mask less than the class full mask. Examples like summary address. Now here, for 192.168, for 192.168.0.0/16, 192 is actually the class C. By default, it should have /24. But when you do the auto summarization, your subnet mask will reduce to /16, less than the 24 by default, right? So in this case, this is called supernet route. Supernet route means that the value of your, by right, your class C should be /24, but then your subnet mask is less than that. So that is identified as a supernet route. So the default route is a static route with the address of all called 0. So you have a 0.0.0.0/, your subnet mask also 0. That is your default route. Okay, next we go for the parent route. It's a level 1 network route that is subnetted. So in the routing table, it basically provides a heading for the specific subnets it contains. So this is just for your info about the parent routes. Okay. And next, also for your information about the level 2 child route, is a route that is a subnet of the classful network address. So you have a level 1 parent routes that contain the level 2 child routes. So the level 2 child routes are also ultimate routes. Remember just now we mentioned the ultimate routes is the one that with either the exit interface or the next hop IP addresses. So your level 1 parent routes, it will contain the level 2 child routes. And then the level 2 child routes will also is a ultimate routes. Okay, router lookup process. If the best match is a level 1 ultimate routes, then this route is used to forward the packet. But if the best match is a level 1 parent route, so the router then examines the child routes. And if there is a match with a level 2 child routes, that is used to forward the packet. So if there is a match with the level 2 child routes, the router searches the level 1 supernet or default routes. If there is a match, that route is used. So if there is no match found in the routing table, the packet is dropped. Okay, now we go for the longest match. The best match is the route in the routing table that has the most number of far left matching bits with the destination IPv4 address of the packets. So the route with the greatest number of equivalent far left bits or the longest match is always the preferred route. Examples like route 1, you have for 172.168.0.0/12. Route 2 will have 172.168.0.0/18. Route 3 will have 172.168.0.0/26. Now, if you look at the one that highlighted in the orange color, the router will have 3 routes to reach to the destination of 172.168.0.0. But which one will be the preferred route that the router will going to store in the routing tables? Now, according to these slides, the router will going to choose the longest match. Okay, so the longest match here will be this route 3. So that means this route 3 the router will going to store 172.168.0.0/26 subnet mask to store it into the routing table to reach to the destination address of 172.168.0.0. So in this case, you are not going to store this, you are not going to store the route 2. Okay. So next we talk about the IPv6. Okay, IPv6 routing table. So IPv6 routing table also includes the directly connected networks. You also have a static and dynamically learned routes, exactly the same as IPv4. And IPv6 also will have the level 1 ultimate routes. Again, the ultimate routes is the one that you have as the interface or the outgoing interface. Okay. Or you have the next hop IP addresses or the exit interface, that is your ultimate routes. Now you use the show IPv6 routes to display your command for the route source, directly connected networks, administrative distance, your metric and outgoing interface. Now all this is the same as the IPv4, just that when you show the configuration command to check all this information, you have to add in the word v6. If you are using the IPv6, okay? So you can show IPv6 route to check your route source, metric, directly connected networks, what is the outgoing interface, and what is the administrative distance value for your router R1. And you can also show the IP route, which is the show IPv6 route, to check your information if you want to check your remote networks route. Okay, so this is exactly the same as IPv4 as well. So here is the conclusion of the topics that we have learned. Okay. Now for your first session just now, I already talked about the dynamic routing protocols, which is the RIP version 2. Then you have the dynamic routing and so on. So these dynamic routing protocols, I already explained the function of dynamic routing protocols, the purpose of what is the purpose? Why do you need to use the dynamic routing protocols? I hope you still remember. The reason is because if your network groove, you have a lot of complexity topology, then you need to use the dynamic routing protocols. And we also touch about the dynamic routing and the static routing. What is the differences between dynamic and static routing, the pros and cons about both. Also, is already covered in this topic as well. And the second part, we already gone through the RIP version 2, and how are we going to configure the router, which is to activate the RIP version 2. So don't forget, you have to type the words router RIP, then you press enter, and then you have to type the word version 2 if you want to implement it. Because if you don't have the word version 2 by default, it will go to the RIP version 1. And the disadvantages for the RIP version 1 is that it will auto summarize your routing tables, and it cannot support the CIDR and VLSM. So you need to implement the RIP version 2 to support the classless routing protocols. And the second one, we already also covered the configure the RIP version 2. How do you activate the RIP configuration and so on. And the last parts, I also covered the routing tables. Determine the functions, the route source, how to identify the administrative distance and the metric. So the administrative distance will be identified by the bracket. The first value here, okay, will be your administrative distance, and the second value will be the metric. Okay, so this is how to identify the route source. AD metric for all the given route. Explain the components of the IPv4. You should be able to know how the IPv4 routing table entries are given, and you should be able to identify the parent and child relationship. And you should be also know how to route using the IPv4 packets and the IPv6 packets. So this is how I summarize the whole topics that covered for this dynamic routing protocols for session 1. In my next session, I'm going to cover the session 2, which is more details about the dynamic routing protocols. So stay tuned with me. I'll see you again for my next session. Thank you very much. Bye.